Hello everyone, I welcome you in the next lecture of 12th class NCERT Mathematics. In this video lecture, we will discuss question number 5 and 6 of exercise 5.2. As we discussed already in 1 to 4 questions that we need in this complete exercise or from now onwards 5.2, 5.3 and up to so on, we will discuss about the differentiability of the given function. Okay, so here another task came that from in 5 and 6 you can see there is a different type of questions are there. So first of all, I will explain what method we need to apply if we see this type of question. Okay, so without further ado, let's get started. Our method, here we will write by the green one. I think it's awesome. Here you can see that your function fx, this is your function fx, above function, denominator function is g of x, okay, and this is you can assume h of x. This is your function h of x equal to f of x upon g of x. Here fx is given as fx is equal to the sine of ax plus b, and your g of x is given as cos of cx plus d. Okay, now so you can see that if both are arguments same, then we can convert into 10 and we can apply simply the derivative of 10 and then chain rule. But here problem is that ax plus b, this one argument of sine and argument of cos, both are different. So it means both are of different arguments. If both are of different arguments, then we need to apply the quotient rule here. What is the quotient rule? The quotient rule is here, you can see, suppose you have a function fx upon g of x, okay, this is your h of x, and if we want to differentiate this function, dh upon dx we need to find, or we can say d by dx of f of x upon g of x we need to find. Then here you can observe that here you can observe that this is your g of x whole square. Okay, first of all we need to do the square of the denominator, and then g of x is as it is, and d by dx of f function. Okay, and here minus d by d of x of the denominator function g and f function as it is. Okay, so this is your quotient rule for the given function dh upon dx. Okay, so I hope you understood that what is our, here you can see this is your quotient rule. Okay, now this is your quotient rule, but here you can observe, yeah, here we can apply easily quotient rule, but problem is that or the thing is given that sine is again the function of ax plus b. Okay, it is not only sine x here, it is sine of ax plus b. So here we need to apply the chain rule again. To find the derivative of f, we need to apply the chain rule, and chain rule we already discussed in the previous lecture that how we can apply. One time I will recall here also, no problem. So here what is given, your function is f of x is expressed as, here I will explain. Okay, wait, here you can see this quotient rule and the chain rule. Here we have chain rule. How your f of x is further expressed as p of x, p of g of x, p of q of x I will take, p of q of x. Okay, so here if we want to differentiate df upon dx, we need to find how we can find derivative of outer function with respect to the inner function. So d by dq with respect to d by dp by dq, and derivative of q with respect to x. Like that we need to differentiate. Okay, so here you can observe how we can apply now. This is your h of x. So h of x, I assume that this is this one, let, and what is your h of x actually? H of x is your sine of ax plus b, and here you can observe cos of cx plus d you have. I hope you understood. Okay, now if you want to differentiate, we need to write the thing differentiate above function with respect to x. We need to differentiate. Clear? We need to differentiate with respect to x. So how we can differentiate? We need to apply the quotient rule. Why the h dash of x also represent your derivative, or dh by dx also, by this one you can represent your derivative. Okay, so what's your quotient rule? Cos of cx plus d whole square. First of all, see the denominator square. Okay, now the derivative of numerator function, cos of cx plus d as it is. Okay, cos of cx plus d as it is, and here wait, I will show something. Yeah, up to here we have. Okay, and here d by dx of a numerator function, that is sine of ax plus b function. Okay, now minus here you can observe that the derivative of the denominator function, that is cos of cx plus d. Okay, and your f is as it is, that is sine of ax plus b as it is. So I hope you understood that. Okay, now separately you can find, make it as a star equation because it is otherwise looking haphazard. Okay, so d by dx of what we need to find, try to make your answer or solution in a very easy manner you can solve. Don't make your answer in haphazard way. Okay, don't make your solution in haphazard. How? Sine of ax plus b. Try to break your solution into parts. Okay, make algorithms. D by dx of sine of x plus b. So it will be cos of ax plus b. Outer function derivative is cos of ax plus b. Okay, and d by dx of what function? Inner function ax plus b. Like that we apply here now. You can see here, this is your d by d. Okay, like that we apply na chain rule. Here you can also, this is your chain rule. Okay, so like that we can apply, and what we get here, we will get cos of ax plus b. Okay, and if we differentiate, yesterday I gave you all the how we can differentiate a polynomial. So it is ax plus b, what will come? A only. The derivative of x is 1 and derivative of constant function is 0. So a cos of ax plus b, this is your first one. Okay, now d by dx of, we need to find for the cos of cx plus d, we need to find, and how we can find cx plus d. Okay, it will be minus sine of cx plus d, and derivative of again which function? D by dx of inner function, that is cx plus d we have, and what we get? Minus c sine of cx plus d. Okay, now what's your dh upon dx? See here, I will write here. Yeah, yeah. What is our dh of dx? Dh we can write here from equation first, second, and star. What we'll do? Put first and second value in the star equation. So what is our dh upon dx will be the d by dx of sine of ax plus b. See, the value of this one by first we determine, and the value of this one we determine by the second. So how we can write, you can observe here that cos of cx plus d, and here the derivative of sin of x plus b is a cos of ax plus b. Okay, now plus again we need to find the again we need to put the value of, now here we need to put the value of this d by dx, and we can find by the second. C minus minus will become plus, and here we will get c sine of cx plus d. Okay, c sine of cx plus d, and wait, yeah, here we will same as that sine of sine of here we will put ax plus b we have. Okay, and here your cos of cx plus d whole square. So I hope you understood the thing. In a more simpler manner, how we can write dh upon dx is equal to the a we can take here cos of cx plus d, and here cos of ax plus b plus sine of ax plus b, and sine of wait sine of cx plus d. Okay, yeah, and c should be here. This is your cos of cx plus d whole square. I hope you understood. This is your final answer. I will put in a blue box. This is your final answer. Okay. I hope you understood. Okay. That how many methods we apply here. So now we are moving toward the our second question. Okay. What is the second question is? That is question number 6. So here it says that I'll change the color. Wait. I'll choose this one. Now listen. Here you can see you have a function here, it is given, that is f of x into g of x. Here product is given. Here it is in quotient format. Here it is in product format, and I assume this is your h of x. Okay, h of x equal to f of x into g of x. Okay. So product rule we need to apply here. What is our product rule? I will explain what is our product rule. Okay. How we can find it product rule. So product rule is our like that you have h of x, here it is given. H of x is in the format of the product of two function f of x into g of x. Okay. Now if we want to differentiate our function, we need to represent it as dh upon dx. Okay. So the derivative d by dx of f of x into g of x. So how we can find this derivative? You can see this one you can assume first, this one you can assume second. Okay, without loss of generality you can assume first and second. Okay, you can assume gx as first and fx as second, it's your choice. Okay, it is not like that we have some condition. Okay, no condition is there. Either you can assume g first or first, it's your choice. So what do we have? The gx will be as it is, d by dx of d by dx of f. Plus is there, operation is plus, and f is as it is, f of x is as it is, and d by dx of g function. Okay, this is your product rule. And again here you can see f is again expressed as a composition function. Okay, and g is also expressed as a composition function. So again we need to apply the chain rule. Actually chain rule is a very important in whole differentiability, and after that also in your application derivative in integral chapter also, because the chain rule is applied everywhere. So please focus on chain rule, that the outer function, what is outer function given, what is inner function given, derivative of outer function with respect to inner function, and hence the derivative of inner function. Okay, so here you can see differentiate our, wait, I will write here, your h of x is given as cos of x cube into sine square x raised to the power 5. Okay, so differentiate above with respect to x, differentiate above with respect to x. Okay, now how we can differentiate, you can see here, but the product rule we can apply, dh upon dx will be d by dx of cos x cube, and the second function as it is sine square x raised to the power 5 as it is, plus here cos x cube as it is, and here d by dx of sine square x raised to the power 5. Okay, now here you can observe that, see, we again will break the our question into two parts. First of all, we will find the derivative of d by dx of cos of x cube function. How we can find derivative of outer function with respect to the inner function, and the derivative of inner function with respect to x. So like that we will find this is minus sine of x cube, and here you are getting 3x square. So ultimate answer is minus 3x square sine of x cube, first equation for this question. Okay, now we need to find d by dx of sine square. I will write in a proper manner. Okay, see here we will apply some good chain rule. How? D by d of sine of x raised to the power 5 with respect to inner function. See, this is how it is actually, you have like that. Okay, the inner function is sine of x raised to the power 5. Okay, so this is sine of x raised to the power 5 whole square is there. Now derivative of inner function. How we can differentiate this one? Again we need to apply chain rule. D by dx with respect to x raised to the power 5 sine of x raised to the power 5, because for the sine is the outer function and inner function is x raised to the power 5. Now again d by dx of, here d by dx of x raised to the power 5. Okay, so what we get from here, you can observe, you will get 2 sine of x raised to the power 5, and here product is there. Okay, here you will get cos of x raised to the power 5, and here you will get 5 into x raised to the power 4. Okay, now we can write in a simplified manner 10 x raised to the power 4 sine of x raised to the power 5 cos of x raised to the power 5. Okay, either you can leave it here or we can write as we know na, in a trigonometry we have formula of sine of 2x. What will be 2 sine x cos x. So we can convert this into here 5 x raised to the power 4 2 sine of x raised to the power 5 cos x raised to the power 5. Okay, so here it will be 5 x raised to the power 4 sine of 2 x raised to the power 5. This is your final one. Okay, now we need to combine both of them. How we can combine? Listen here. Okay, yeah, in star equation we need to put, so from wait from equation first, second and star, what we have dh upon dx is equal to the dy. We need to differentiate na, d by dx of cos x cube, and cos x cube derivative is this one. For this one we have the derivative is this one, that is minus 3 x square sine x cube. Okay, and here sine square x raised to the power 5 plus, now derivative of cos cube x. Okay, cos will be derivative is, okay, derivative of sine square x. Okay, cos cube x is as it is, so here I will write cos x cube as it is, and the derivative of this one complete function is determined by the second one, so it will be 5 x raised to the power 4 sine of 2 x raised to the power 5. Okay, this is your final answer. It may possible that I will tell you one more thing. This one you can take. Final answer. Okay, it may possible that here that they leave your answer up to here only. Okay, so if they are writing this answer by writing here, so no worry, you more here you more simplified your answer. Here what you did, you more simplified answer you are giving from here. Okay, so it is not a problem that you are giving your answer in a more simplified manner. Okay, this is your answer also, and if you put this thing in place of this one here, if you put this thing in place of here, then also you got the answer. I hope you understood here what we learned from these two questions, that how we need to apply product rule, and how we need to apply the quotient rule here for a given question. And in a quotient rule, in a product rule, again we need to apply the chain rule. Actually, it is a complete mixture, fifth and sixth, both the mixture of a quotient rule, product rule, and the chain rule. If you have any doubt, then you can ask me in comments. I will rectify your query there, or I will make some other video if not rectify there. So thank you for watching.